Hi everyone. We're really excited to be part of FM Tech Week and continue this week's discussion on innovations in FM. In this session, we're going to explore the potential for smarter operations with connected data and continuous intelligence. We will look at why a full lifecycle approach is essential to preserving asset context and design intent as assets move from design and construction into operations. I'm Susan Clark, and I'll be co-presenting today with my colleague Adam Peter. We're both part of Autodesk Operations Solutions. Here is our roadmap for today. I'll be kicking off this session with some industry context, looking at why data flows break across the asset lifecycle and why this matters. Next up, Adam will explore what fragmented data means for facility operators and how digital twins can play a key role in helping us connect this data. To set the stage, I'd like to take a moment to explain why this topic is so important to the industry and why we're discussing it today. In recent years, we've seen the massive rise in the use of data in facilities management. As facility leaders are collating more and more data, they are increasingly recognizing that high-quality data is a team sport. To achieve reliable data across assets, spaces, and building systems, facility managers often need to engage a broad range of stakeholders in the ecosystem. And this includes their counterparts in design, construction, and also general contractors. Nearly all facility managers today are looking to utilize more and more data from the AEC process. But very often they find themselves unable to access, trust, or use that data once a project moves into operations. Now, as many of us on today's call know, there's lots of complex and multifaceted reasons behind this break in data flow. And while we'll explore the top line today, I do encourage you to take some time to check out some research that Autodesk produced in partnership with the IFMA IT Community. In this research, we explored the importance of taking a lifecycle approach to data management. And we also explored the potential role that a digital thread could take as a framework to help us flow data from design, construction, and into operations. Our research also included a survey with over 200 facility managers globally. And we'll be sharing a few of these insights as we start to explore the challenges and opportunities of connecting data across the facility lifecycle. Let's start by taking a step back and looking at the full asset lifecycle. Arguably, operations is the most strategically significant phase. It represents 60 to 80% of total lifecycle costs, and is where most of the life cycle value sits, as assets are managed, optimized, and renewed. But success in operations is also tied to the rest of the life cycle, such as decisions made in the design phase, and also how well data flows from construction into handover. The point here is operations does not exist in isolation. If data becomes disconnected or lost along the way, it becomes much harder for operational teams to manage, maintain, and optimize assets over their lifetime. So despite the strategic importance of operations, the reality is many operational teams are constrained by siloed systems and missing data. What is still common in the industry is that data produced during design and construction is not always handed over in a structured or usable format for facilities management teams. And as a result, many operational teams find themselves struggling with insufficient handover data, and in particular, missing insights on design intent that can contribute to different efficiencies that we see in operations, particularly those around asset management and maintenance. So what is behind this? I often say that bad operational data starts with a poor handover. But there are actually many poor handovers if we look at the full life cycle. This can include the handover from planning to design, design to construction, and then the one we're talking about today, construction into operations. As we can see from this chart, data is created at each stage. It is changed and handed off. But too often, there are often breaks in that flow. Information gets lost, becomes outdated, or is delivered in formats the next team cannot easily use. And by the time we reach operations, teams may be working with incomplete or unreliable information. This often forces facilities management teams to try to recreate data that has already existed, wasting time, duplicating effort, and potentially introducing new errors. This creates what many call the outcome gap, the difference between what connected data could deliver and the fragmented reality that many operational teams face today. So what is the scale of this problem? Industry research from FMI shows us that as much as 95% of design and construction data goes unused. So whilst it is true that not every piece of data or every document should be passed along the value chain, this highlights the significant disconnect between the data being created and the information that is ultimately available and trusted in operations. In many ways, the challenge is not that we're creating insufficient data. It's we're not effectively carrying the data forward into operations or to the next team where it can deliver the greatest long-term value. So what is holding us back? Our research with the IFMA IT community pointed to a mix of people, process, and technology challenges. One of the standout data points for me was that facility managers are often not consistently involved in the design process, and this limits their ability to help define and shape the data that they will receive in operations. The global survey we ran found that 80% of facility managers are not consistently involved in design processes and data decisions at the start of the lifecycle. The research also highlighted that handover is still a major pain point, and many teams wait months or even over a year for complete closeout information. And when it arrives, it may feel very difficult to use or feel incomplete. And third, we also heard that systems are not always very well connected. The facility managers told us that BIM models, project data, and operational tools often feel like they sit in very separate places. And this makes it very hard for information to flow across stakeholders and the life cycle. And together, these gaps, these challenges, are making it very difficult for facility teams to fully use the data created during design and construction. So what data are facility managers actually looking for? We decided with our global survey to ask the question, what data is needed for successful facilities management? And as you can see from this chart, the answer wasn't a single data set. They need a broad range of information. They want financial and budget data, insights on energy and sustainability, workplace space, and occupant insights. But two data categories really stood out amongst the rest. The first is current asset condition data, and the second is asset lifecycle data. Now, clearly, this data is produced across the lifecycle. Current asset condition data may be produced through a range of different actions. It could be produced through sensors, facility condition assessments, or visual inspections. But asset lifecycle data is something that is created and accumulated through design, build, and construction. Another question we asked is, where can AEC data create the most value in operations? And you can see a bit of a trend building. Again, asset management comes to the fore, reflecting that maintenance teams rely really heavily on accurate asset information, whether that's things like equipment specifications, warranties, maintenance procedures, or maintenance history. And again, this is data typically produced not in one phase of the life cycle, but across the full value chain. So I've spent a fair bit of today looking at what isn't working. We've identified there's fragmented data, disconnected workflows, and gaps between stakeholders. I'd like to finish this kind of first section by sharing the good news. And the good news is that now is a real moment of change. As we've been discussing throughout this full FM Tech Week, facilities management is becoming more data-driven. And the industry is starting to relook at how we can solve some of these long-standing breaks in information flow. We're seeing more focus on stakeholder collaboration, and also the emergence of technologies such as digital twins that can really help us build a stronger digital thread across the asset lifecycle. And what has been very clear through our industry research with IFMA is that facility managers are in a prime position to lead change. They can proactively coordinate stakeholders. They can take a bigger role in defining BIM requirements and establishing digital handover processes. And ultimately, they're well placed to bring greater connection across the facility lifecycle and ultimately improve how data is shared back to them, as they'll be the long-term stewards of any facility. So that is some industry insight and context. I'm now going to hand over to Adam, who will help us explore the potential role of digital twins. Over to you, Adam.
In today's session, we're going to cover three main topics. First, what we've heard from customers about the state of facility operations. Second, I'll transition to discussing why digital twins are so helpful to the world of facilities. And third, talk about Autodesk Tandem, our digital twin solution for operations. Okay, let's get started. Throughout our conversations with operations and facility teams, we see that most experience similar challenges. It's not that there is a lack of data, but that data is everywhere. So much so, in fact, that it can be difficult for downstream users to understand what information is available and how best to find it. Downtime is not just a production line problem, but any slowdown has a downstream effect on stakeholders. From a pump going down to a meeting room being unexpectedly unavailable, the disruption costs time, which is money. It's not just data. Over time, you've likely implemented BMS systems, CMMS, IoT, space tools, ERPs, and more. Ensuring that these systems are integrated with each other and into your overall workflows are critical. We believe the future for facility management is a world where we help turn complexity into simplicity. We do this by providing a system where stakeholders can see all the facility data in one place and in context. We create an environment where teams can predict failures before they happen and make a proactive plan for prevention or mitigation. We envision a world where smaller teams are empowered to accomplish more because the systems help them find ways to be more efficient. And by having one shared source of truth, teams can be more confident to make decisions that matter, and facilities are more resilient because disruptions are minimized or removed completely. Digital twins have been quite a buzzword over the last several years, but what exactly is a digital twin? Well, the digital twin is a digital replica of a built asset, and it puts all the information about the physical asset at your fingertips. Bi-directional connections between the physical and the digital enable the twin to possess the operational and behavioral awareness necessary to simulate, predict, and inform decisions based on real-world conditions. The challenges are real. You're not just managing assets, systems, or spaces, but you're also managing time series data, events like alerts, work orders, state changes, and emerging AI-driven recommendations. Because the context between these elements is often disconnected, it can leave you operating in the dark or losing time manually in making those connections. The Autodesk solution, Tandem, is a digital twin that connects all of those physical assets with the operational data and the business events that occur. So your team sees what matters in context, not just raw data in spreadsheets. Tandem becomes the system of context. It connects IoTs, BMS data, CMMS, and ERP data, smart meters, and space tools, just to name a few. And the reality is that Tandem does not replace your existing systems. It connects and contextualizes them. Instead of logging into 6 platforms, your team sees assets in the space they exist and in an intelligent environment. And their data, therefore, becomes much more actionable. Digital twins are not just for one industry, by the way. It supports commercial real estate, manufacturing, government, airports, healthcare, retail, and education, just to name a few. Now, this matters because we know that oftentimes facility teams are managing assets across multiple sites and cover a diverse set of asset types. So Tandem scales to meet the need, and it standardizes how you manage performance across your portfolio. With digital twins, and specifically Tandem, the goal is to simplify access to complex data and to enable stakeholders to consume that in meaningful and productive ways. So let's take a look at this in action. So in our example today, we're going to look at a couple different facilities from a couple different perspectives. Our first facility is going to be a factory, which you can see the overview here. And what we're going to do is switch to the perspective of a facility manager who is looking at work orders. And so very quickly we can sort of get some perspective about this facility and the different workspaces. You can see I have each of those color coded. So we just get a quick overview of the layout of this facility. And you can see if I were to hover over some of these icons that we have some work orders that have been created within this facility that we're going to look at today. Now, from the perspective of a maintenance manager, we might already be working in some system like Maximo or MaintainX where they're managing work orders. However, Tandem has the ability to bring those work orders in and give them some contextual awareness along with any other information that we might need to know about a particular asset, which we'll see in a minute. We have this inventory view, which might look very familiar to someone who's working in another tabular system. I think one of the things that we can see here very quickly is a comprehensive list of the work orders and then what might be missing on those tickets. So just from a high level perspective, as I come in as a manager and I'm looking to sort of assign these work orders, I might look at one of these and start to say, okay, well, I'm missing, some particular date. In this case, right, there's like no date or priority to this specific work order. So maybe I would come and actually fill these in. And because this is tied to my actual maintenance system, when I make modifications here, this would get pushed back into that system. where Susan mentioned earlier in the process where oftentimes we get siloed information, and instead of needing to go to 3 or 4 different silos to find out information about a particular asset, or in this case work orders, I have this sort of single view that I can do everything I need to here. And not only that, I can take this, for example, and filter this out. Maybe I want to look at priority that is just critical or high. So these would be open tickets that are set with a high priority. Or perhaps maybe I want to be able to see everything, but I want to group it by priority so I can get a feel for how many we have in each category and start to prioritize them that way. So we have a number of different ways that we can view this information, even just in the inventory. But I think what is maybe equally powerful is to pick on an asset and just to talk very briefly about either the handover process or what information we can gain about an asset. Well, we have a lot here just in this particular example of not only having information about this particular asset, but all of the handover data that we would have gotten as well, like the data sheet, the manual, warranty or spec information, as well as the context of operational performance that we can see at any given time as well. And again, traditionally, we would likely be going to multiple systems to get this information, where this telemetry data might be in a SCADA system that we're looking at, where any of the manual information might be kept in a folder somewhere on a network drive, and any kind of maintenance information would perhaps be in another folder or in another system, and certainly any cost information, this might likely reside in a spreadsheet somewhere where we've pulled data out of a couple different costing systems, operating performance systems, and aggregated in a spreadsheet, and that gets put in another folder, right? So the idea here is just that, again, a digital twin is giving us information to all of this data in context, and that's where it really gains a lot of strength. So as this maintenance manager, another way that I have to view this information is through the tickets panel. And very similar to the inventory, I can look at the status of open or closed tickets. I can group these by priority, or if I want to look at just the critical tickets, well, there isn't any critical, but let me go back to high, for example, and we know that these are open. And these filters, of course, can be also managed, so I might want to look and see with these tickets, who are each of these assigned to. Maybe I would want to actually organize it by assignee, so I can see, okay, I have a number of tickets that are sort of outstanding, and it looks like Morgan has quite a few, but 3 of those are low. So if I am trying to organize or plan work for the day, this gives me a nice, convenient way to sort of see what the workload is for each person. And because they're tied to physical assets, I can scroll through and see where each of these work orders are taking place. Because maybe for work balance, I don't want to send Morgan to 5 different areas within this factory. Maybe Morgan's just going to work on a specific area, or I'm going to balance those between low priority and medium priority, where Jamie maybe has like something that is going to be high priority. So as a manager, it really offers me the opportunity to, again, see where each of these tickets are taking place. For each of these tickets, I can get information about the actual host that it's attached to. So this happens to be attached to a case packer, so I have the contextual awareness to know everything I need to know about that particular case packer, if there's been other previous tickets that are associated to that piece of equipment, all become usable and relevant information all in one place. I don't need to go outside of this system, even though I can interact with all of the data. Likewise, if I happen to be Morgan and I came into work that morning and I wanted to see all of the tickets that were associated to me, this is a great way for that user to also prepare for the work that they have for that day, because they can, again, look at that ticket and get all the information that they need about that particular piece of equipment. In another example, I'm going to go to this office, and very similar to what we had in the previous example, if I were to pick on this VAV unit, maybe we know that there's some work that is going to have to happen. Because I have this in graphical context, I know exactly where I'm going to need to go to get this work done. I happen to also know what space or room this is in. By selecting that room, I might be able to get information about, like, for example, how tall the ceiling is. So I know if I need to get an 8-foot ladder or a 10-foot ladder to be able to service that particular VAV valve. Or maybe we know that we're going to do some work on that, and we're going to need to take the AC unit offline for a while. So maybe I would want to go back to where that coil unit is to be able to do some work on that whole system. And if we were to shut that system down, perhaps we would like to know what rooms are going to be affected by that, so we can send out some notification to people that are going to be in those rooms. Of course, if we're tied into a room booking system as well, we could perhaps project throughout the course of the day which of those rooms are going to be occupied, and notify the leaders of each of whoever booked those rooms, and notify them that there's going to be an outage. Rather than blasting the entire office with an email or notification, we can limit it to just those people that are immediately affected with those room bookings. And again, as I mentioned before, because we have this all in context, we have all of the information about this asset that we would likely need to be able to do that work, all in one system, which is a great benefit here to us. We could also look at performance history over time as well. So as just for example, if we were looking at temperature, we have the ability here to actually look back in time and sort of get a better feel for how our building is performing throughout the day, and where we happen to have hot spots. As an example, in this particular room or layout, we know that oftentimes in the afternoons we get some hot areas because the sun is on a particular side of the building. And again, from a maintenance standpoint, maybe that helps us schedule some blinds that close on that side of the building in the afternoon to try to keep overall temperatures or comforts down. And with that history and that context, and we know that that's going to be a thing, it allows us from a maintenance standpoint to reduce cost and to increase the comfort level for people in the office that are in during those periods of time. So this is just a few examples where I think it's relevant, and hopefully you'll see how much a digital twin specifically can benefit a facilities team. On behalf of both Susan and myself, we want to thank you very much for attending this session.